So in terms of our agenda today, we'll start by giving a quick overview of Spire Global at a company level, and then dive into a more detailed overview of our different products. So first we'll run through our Stratos, or our weather and earth information product, and then we'll talk about our hosted payloads and custom CubeSat products. And then we'll walk through our Sense product, which is our AIS or ship tracking, and then our AirSafe product, which is ADSB or aircraft tracking. And then we'll spend a bit of time on kind of what civil applications and use cases we're thinking about for the future. And then we'll hand it over to Keith at 40Geo for kind of a visualization and example of how Spire data can be used to tackle some of those use cases that you have. And then finally, we'll end with the Q&A. So just a reminder, you can ask questions throughout using the question function, and we will just address those when we get to the Q&A at the end. So now I'm going to kick it over to my colleague, Keith Johnson. Keith is the VP and GM of Government Solutions for Spire and the head of our Spire Federal team. And so he's going to give you a bit of background on kind of the history of Spire and our federal business and what some of our goals are moving forward. So Keith.
Perfect. Thank you, Jamie. Thanks to the civilian team as well, and thank you all for joining. We certainly know that these are extremely abnormal times, and we're all working really hard to return to business as usual, and we're not sure how that's going to look. But I would tell you that even during these times, Spire has been on explosive trajectory quarter-over-quarter growth. And so we're really pleased that you took the time to join us, and we look forward to sharing our story. I would add that this is our third webinar, and the attendance has been exceeding our expectations, so thank you very much. So what I thought I would do is spend a few minutes about our history and our vision and our successes, and they'll be reinforced throughout the presentation. But I think one interesting fact is that Spire was founded by three individuals: Peter Platzer, Jeroen Kappert, and Joel Sparks. And they were at the renowned International Space University, and they were looking at opportunities in space, and they determined that Earth observation or listening from LEO was where they could have their most impact on the planet. I would tell you that Spire is a very strong humanistic company, and so worrying about illegal fishing or human trafficking, to locating lost planes, or to providing better weather data to help with climate change or to save lives and infrastructure due to severe weather was paramount in their ideas about building the company. So we founded in 2012, and we were specializing in data gathered from a network of small satellites. Our first satellite, which is a lemur, which is low Earth multi-use receiver, went up in 2014 on top of the Soyuz rocket. As you'll hear later, we've got 88 satellites in orbit supported by 31 ground stations, and we're real proud of that. By the way, the purpose of the first mission was to demonstrate the satellite platform and support systems. It wasn't about putting operational payloads. But that was a year later in 15 on Lemur 2, where we put 4 satellites atop an Indian PSLV launcher, and we introduced Stratos and Sense, which you will hear about, which is our AIS and weather. One thing about Spire is that we do incremental improvements on every launch. And so we like to say we launch and learn. So we're iterating on all of our efforts, and it really pays off on our capabilities. And by the way, we're building towards about 175 satellite constellation. So we now currently have offices in San Francisco, Glasgow, Singapore, Luxembourg, Boulder, Colorado, and DC with around 220 employees. I started the federal business unit in 17, and in less than 3 years, we have around 15 people, and I like to say they're all subject matter expertise in federal business, and so we can really help when you have conversations about anything to do with how do we work within the federal space. And that is run by Steve Moran, who you'll hear from shortly, who him and his team are doing a great job, so we really appreciate their effort. The other thing that we've done is we've built an ecosystem of partners to help with the visualization and providing data analytics to our data to support the warfighter's mission. And they're made up of, as you can imagine, MapLarge, Esri, ArcGIS, BAE, and of course, Keith Fraley at 40Geo helping us out a lot. So at the end of the day, what do? We design and build satellites every week. We launch every 6 to 9 weeks, and we're collecting about 1.4 gigabytes a day of data, and that's going to continue to grow. And then we process that data, we apply machine learning and AI processing to come up with a product, whether it's AIS or ship tracking or ADS-B or weather. So we're real pleased with those products. They're very mature. They have a tremendous footprint already. When you look at our AIS ship tracking, things that you would think maritime domain awareness concerned customers, whether it's NGA or Coast Guard or Navy, are all looking at and using our product. When it comes to ADS-B, we have people like URSA. We've had conversations with the transportation commands and FAA. Our weather's been widely bought and used and reviewed by people like NOAA and NASA and Air Force. We have a new product out that you'll hear about, our numerical weather product that's being tested that is showing some great results. And lastly, we have our orbital services, which if somebody wants to have a sensor put in space in less than 6 to 9 to 12 months for very low cost, we can do that. We have many proof points. We have KeyW, which is going to have 3 satellites up. We have a Five Eyes customer, and we're in many other discussions. So we're real pleased about that, that focus as well. So I just want to say a few things, and I want to say thanks again for joining us, and I hope you find these presentations interesting and helpful. If you need anything, please ask. If we've got plenty of white papers, trial data, or any additional information. But thanks again, and appreciate your support. So I'll throw it to Janie and Steve.
So this is Steve Moran. I run the civil team here in Spire Federal. I would like to extend my thanks also to everybody who's joined the webinar, especially those who are joining from overseas. I know it's late there, so we really appreciate you staying late to learn more about Spire. Just a little bit on my background. I came to Washington in 1990 to go to work at NASA headquarters. I worked there for 10 years. I spent 5 years in the White House Office of Science and Technology Policy, and then went back to industry and I was with Raytheon for about 17 years before joining Spire Global. I joined Spire last December, so I've been here about 6 months, and I got to tell you, it is a really exciting company. Lots of young, smart, energetic people and amazing capabilities. So with that, I'll go to the introductory slide. As Keith mentioned, we're a CubeSat-powered space and data analytics company. We currently have a fleet of 88 3U CubeSats that have passive RF sensors for AIS, ADS-B, and GNSS-based Earth observations. And we have our own weather forecast capability in-house that leverages our unique GNSS-based radio occultations, and I'll talk a little bit more about that later. And then also, like Keith mentioned, we offer hosted payloads and custom CubeSats. On the next slide, and Keith talked about this a little bit, but I just wanted to mention that we introduced our first AIS capability in 2013. We launched our first radio occultation or GNSS receiver with radio occultation capability in 2016. And then we introduced space-based ADS-B for aviation tracking globally in 2017. We have 88 CubeSats on orbit. They're all 3U CubeSats. And we have additional launches scheduled later this month and in July, and we should hit 100 satellites in the July-August timeframe. Keith already mentioned that we were founded in San Francisco. This slide shows our 88 CubeSats, but we also have our own in-house ground station network of currently it's about 32 ground stations globally for command and control and data downlink. We build on average 1 CubeSat a week to every week to 10 days in our Glasgow manufacturing facility, and we launch on average about every 6 weeks. Each of our current generation satellites carries 3 primary payloads. an AIS receiver for maritime tracking, an ADS-B receiver for global aviation tracking, and a proprietary science-grade GNSS receiver that was developed and is manufactured in-house. And we also offer hosted payloads and custom CubeSats in both 3U and 6U configurations. This just shows our current constellation and the orbits that our satellites are in right now. They range from equatorial to polar orbits, and as you can see, the majority of our satellites are actually in polar orbit, so we have really good coverage of the polar regions. And then this slide shows our current ground station network. I mentioned we have 32 ground stations that provide us true global coverage, and we continue to expand this network to improve both our coverage and to reduce our data latency. Just for a second, I want to talk about our security approach. Our data is fully encrypted from the time it's collected by our satellite instruments through transmission to and through our global ground station network and into our US-based cloud processing and data dissemination service, and then out to our customers through our standard and custom APIs. End-to-end encryption and security is prioritized throughout our system. One of our advantages is the fact that we're vertically integrated. Everything except for the satellite launch we do in-house. So it gives us an unmatched level of control over our system, and then ownership of the satellite design, manufacturing, testing processes, constellation operations, data processing and dissemination, and data delivery enables speed, reliability, agility, and control. And with fewer dependencies on external providers, we ensure the highest quality of data with the lowest risk possible. We serve 4 major market segments. As you can see here, Sense is our maritime domain awareness capability. Stratos is our Earth observations and weather forecasting products and data. AirSafe is our air traffic tracking capability, and then custom CubeSats and hosted payloads. We also provide fused products such as maritime weather forecasts combined with AIS ship tracking to enable our customers to improve the safety and efficiency of their operations. I'm going to cover the Earth observations, weather forecasting, hosted payloads, and custom CubeSats. And then I'm going to turn it over to my colleague, Will Cromarty, to talk about AIS and ADS-B, and then Keith Fraley from our partner 40Geo to address AIS, use case in AIS. So let me jump right into our Stratos and custom products and capabilities. One of the foundations of our Earth observations capability is our in-house designed and manufactured science-grade GNSS receiver. Our CubeSats are capable of observing the signals from the various GNSS constellations like GPS, GLONASS, Galileo, QZSS, Beidou, and some others. Basically anything that broadcasts in L-band. And we look at those signals as they transit the atmosphere from their source satellite to our CubeSats. And as those signals transit the atmosphere, they're refracted or bent in the same way that light passing through a prism is refracted. And by accurately measuring the bending angles of those GNSS signals as they pass through the atmosphere, we're able to calculate atmospheric properties such as temperature, humidity, and pressure. And this process is called GNSS radio occultation. It's been proven over a number of years. NASA and NOAA have evaluated our radio occultation data and some of our other data. I'll describe that a little later. And radio occultation provides very important information for numerical weather prediction models. In addition to radio occultations for obtaining highly accurate atmospheric properties, our sensors also collect information that's important for space weather monitoring and prediction. Each of our GNSS-equipped satellites can measure total electron content of the atmosphere, which is an important indicator of solar activity and geomagnetic storms. We also produce ionospheric scintillation indices, which are important for detecting ionospheric disturbances that affect GNSS signals. In December of last year, we launched 2 new satellites that that are able to look at the GNSS signals as they bounce off of the surface of the Earth, and that's called GNSS reflectometry. And this is another science that has been proven out over the past probably 10 years. And from these measurements, we're able to derive Earth surface properties such as ocean surface roughness and wind speed, sea surface height, sea ice height and thickness, and soil moisture content, as well as monitor wetlands extent. The science-grade GNSS receivers on both our radio occultation and reflectometry satellites also produce really precise information on the orbits of our satellites, and that information enables observations of things like satellite drag, thermospheric density, and other important geodetic information. So let me just talk for a minute about how NASA and NOAA are using our data in the US. NASA completed an initial evaluation of our radio occultation, reflectometry, and precise orbit determination data in 2019, and they published their report in April of this year, so just a few months ago. If you're interested, I can get you a link to their evaluation report on our data. We recently completed delivery of 6 months of historical Earth information to NASA for use by their researchers and NASA-funded researchers under what's called the Commercial Smallsat Data Acquisition Program. And we'll continue to provide daily deliveries of 1-month-old historical data on a daily basis through May of next year. NOAA has also evaluated our radio occultation and total electron content data as part of their commercial weather data pilot program, and their evaluation report should be released within the next month or so. So keep an eye out for that. We're looking forward to it. Some of the other international agencies like the UK Met Office and I believe ECMWF have also evaluated our data and have reports out on their findings. NOAA is going to start purchasing operational radio occultation and total electron content data under their commercial data purchase program later this year, and they'll begin assimilating this data into their operational numerical weather prediction models. In addition to our Earth observations capability, we've also developed an industry-leading in-house numerical weather prediction capability. We assimilate our own unique global radio occultation data into our NWP models to produce a highly accurate global high-resolution weather forecast. Our short-range weather forecast is produced 4 times a day, and our medium-range forecasts are produced twice a day. We produce more than 50 global weather variables in every NWP model run, and these are output as a 12-kilometer gridded forecast for the entire planet. In addition to surface parameters such as air temperature, humidity, and wind speed, our models also produce vertical weather forecasts for aviation flight levels up to about 45,000 feet, or isobaric levels up to about 80,000 feet. And this chart just shows the process that we use for combining the Spire run numerical weather prediction models, which are the FIM model from NOAA and the MPAS model from UCAR, with output from other global NWP models such as GSF from NOAA NCEP and ECMWF from the Europeans, to produce a multi-model global weather forecast that takes advantage of Spire's unique global radio occultation measurements. So we believe this is one of the best weather prediction capabilities in the world right now. This just shows the various weather variables that are produced by each of our forecasts. We package these variables into custom data sets that are designed for specific users, such as maritime, aviation, agricultural, and renewable energy. And we also create custom data sets to meet any user's unique needs. But we continue to expand this set of variables. I think we're upwards of 60 variables now, and getting a lot of interest in our in-house forecast capabilities. Another thing we do with our weather forecasting is we leverage our global high resolution forecast to create point optimized forecasts for specific locations that take into account local terrain, man-made structures, local sensor sources, historical weather behavior, and our radio occultation measurements to produce highly accurate localized forecasts. We call these point optimized forecasts. And we're currently running point optimized forecasts for more than 5,000 airports worldwide, and can create these localized forecasts for any location on Earth. We just need a latitude and longitude and can produce these point optimized forecasts. And the last thing I'll talk about just briefly is our hosted payload and custom CubeSat capability. We offer both 3U and 6U configurations. We've got customers for both right now. You can see some of our specifications in the left column there, some of our customers on the bottom left. And our on-orbit success rate is pretty much unequaled in the CubeSat industry. And we offer low cost, high reliability, and rapid turnaround to our customers. So with that, I will turn it over to Will Cromarty to talk about our Sense and AirSafe products.
Thanks, Steve. Hey everyone, this is Will Cromarty. I just joined Spire a little over 2 months ago, and prior to that I was working in the US federal government as a space policy expert, and then I was doing emergency management work prior to that, focusing on disaster mitigation. So what I'm going to do here is run through Sense and AirSafe, and then I get to my favorite part, which is talking about some interesting future applications of this as well. So starting off with Sense, this is our maritime domain awareness solution that's based on the AIS transceivers that are on basically any large vessel. So through this, we're able to track a little over 350,000 unique vessels on a daily basis. That information gets put out into an API that fits into really whatever sort of GIS system you're using right now. So whether that's MapLarge or any of the Esri solutions, it pops out into a format that works for that. So in terms of applications of this, we see kind of a mix of public sector and private sector applications for this typically. The private sector often has an interest in the economic data that you can glean from this. You know, if you look at global patterns over time, especially in the context of a crisis like COVID, you can look at exactly how those shipping patterns change over time. In a logistics sense, you can think about things like fuel management. And then in a public sector, governmental sense, there often is interest on topics like search and rescue, pinpointing signals, also just general commodity information, and then also some interesting applications for sanctions enforcement that I can talk about in a bit. So this is a view here of all of that data that we're collecting, and essentially this is a mix of information that is satellite derived, terrestrial, and then our own in-house dynamic solution that I'll talk about too. So as I mentioned, this was for over 350,000 vessels. This is covering 90% of global trade, and it also covers vessels in locations that are traditionally difficult to cover, including high traffic zones. So for high traffic zones, we have a solution that we call dynamic AIS. And essentially the background on this is AIS data is, it was never originally intended to be collected from space. And so when you put a lot of these in one location, like for example, in East Asia, you get a lot of very crowded ports. You put all these signals in one location and they start interfering and canceling out. And so it's especially difficult to collect that data for high traffic ports. It's kind of a notorious problem in the industry. And so we developed our dynamic AIS solution, which marries up this data with other sensors locally, and we're able to provide insight into these high traffic ports in a way that other providers typically can't. So on the aviation side, if you take a look at what you would get with terrestrial coverage versus global coverage, you see there that understandably when you have all of these sensors that are based purely in a terrestrial location, you start losing that data in remote locations. So that could be a flight going over the middle of the ocean. That could be a flight in Alaska or a polar region where you might have fewer sensors. It really could be any kind of remote location like that. And so essentially what we're doing here is we're fulfilling the ICAO mandate that happened after a number of unfortunate aviation incidents where planes went down. So this is for 4D15 compliance. Essentially, the ability to know where any flight is with that 15-minute reporting time and doing that in 4-dimensional space. So as I mentioned, given that we have so many satellites in a polar orbit, we're especially good at covering polar regions, Alaska, the Arctic, oceans, all those locations that are traditionally pretty difficult to cover for ADS-B. So one of the places where things get really interesting is when you combine these and you also look at them retroactively and in a forward-looking sense. So this is an example of combining sense and stratos. So what you see here is one specific vessel, the one right there that's Singapore flagged. And if you look at that purple line, because we're collecting all this data and storing it historically, that's where that vessel has been going back in the past. And then you see that smaller white dotted line, and that's us using our own predictive capabilities to tell you where that's going to be in the future. So essentially, you can look in the past, you can do forensics on where that specific vessel has been. If you had a law enforcement or government interest in a certain vessel who was violating sanctions or being a bad actor in some sense, we can not only tell you where they've been and what they've touched, but also where they're headed. And then by clicking on that vessel, you can also look at any number of data points about their IMO number, their call sign, what kind of vessel it is. And then, of course, you see this in the broader context of the weather forecast. So, suppose this was a good vessel, not a bad one you were trying to catch. You might have an interest in protecting this vessel from inclement weather, and you could get real-time updates on that vessel of exactly what you're going to encounter ahead of you. So another potential combination here, suppose you had a port that you wanted to manage. This is the fusion of Sense and AirSafe. So in this context, you can look at all those flights that are moving around, exactly where the local airports are. You can see all of the vessels that would come in and out of that port. Because we have that historical data, you can even consider where they've been. So in a COVID context, for example, if you had a vessel that was coming from a known hot zone that had issues with coronavirus, you might have an interest in knowing that data about that vessel and thinking about what ports they've touched historically. So in both a security sense, an epidemiology sense, and then also a sense of exclusive economic zones that a nation might have an interest in protecting, this is an example of how you'd marry up those two. So this is another favorite of mine. This is some work that we did for FedEx. And what you can see here is a hypothetical flight path. And then that horizontal bar on the bottom is exactly what kind of weather they would encounter along the way at certain altitudes based on the atmospheric data that we collect. So you can say in a fleet management sense, if we started flying from point A to point B, what's that going to cost us for fuel based on what kind of weather we're going to encounter, what kind of winds, what kind of turbulence. And in a real-time sense, if you have an iPad and you have some degree of internet connectivity, you can be the pilot in the cockpit here, and you can look at, there's sudden turbulence coming up in front of me. I better lower my altitude in order to avoid that and protect the craft. So just as a summary of what we've been going over here, through these 88 satellites on orbit and a little over 30 ground stations, we're solving these notorious issues that a lot of people have faced for a long time. We're doing that through maritime and aviation tracking, Earth observation, global weather forecasting, also our hosted payloads and custom CubeSats, and then fusing those solutions into those 2-in-1 packages like the slides that you just saw. And then we also have a lot of exciting things on the horizon that we're focusing on right now. We're focusing on improved RF signal processing, doing even more work on that reflectometry, because there are a lot of really interesting things you can learn from reflectometry. There have been experimental uses of that for anything from oil slick detection to sea ice. So we're doing a lot of interesting work on that right now. We're also looking at embedded AI computing through some specific hardware upgrades. Chip scale atomic clocks, which will be incredibly valuable for PNT work or position timing and navigation. That also plays into RF geolocation efforts. Upgrading to X-band downlink, and then also doing RF intersatellite links. So for my favorite part, this is the future applications. This is my favorite because I get to help dream up some of these and think about some new applications that we can use this for that could be incredibly good for the world or for certain nations or certain government agencies, and use this in a creative way that maybe we haven't in the past. So I'm going to run through 5 of them here. So just as one application, suppose you have a spaceport and you'd like to do forecasting. This is a topic that's growing over time. Currently, there are 12 certified spaceports, and they've just announced that there are 9 more on the way. So, I'm viewing this in an American context with the FAA, but if you had, a specific spaceport in a different country overseas that you were looking at doing forecasting for, what you could do for this is you could combine that point forecast on the ground level for specific geo coordinates. So you could look at what are the exact launch conditions that I'm going to have at that launch. And then you could combine that with the upper atmospheric forecasting we're doing to say, okay, once that launches, what am I going to encounter along the way? Another one that I've been spending a lot of time looking into lately is unmanned aerial systems, or drones. So this is another big push that's happening right now, and there's a lot of really interesting work that the FAA is doing in building out the ecosystem for commerce-related drones and drones in more urban areas. So there are currently 7 different UAS test sites, and they each have kind of their own specializations on what they're studying. But ultimately, they're looking at the question of what it looks like to have a UAS ecosystem that goes beyond just visual line of sight and what you can see in a large field where you're running a test, and goes into what happens when one of these flies over a crowded area, and how do we manage that and manage safety risks associated with that. So that creates a need for highly localized wind speed data, both for experimental testing and then also in a broader sense. And then there's also an ongoing question of how the UAS sphere fits into air traffic management, which is something that, of course, we do with ADS-B. So just one spin-off of this is NASA's AAM program, or Advanced Air Mobility. So we regularly participate in these calls and discussions, and this is a program that NASA is running where they look at this future ecosystem of UAS transportation in an urban context. And it's essentially the question of what does the world look like if Uber starts getting into aerial transportation, and especially does it in a UAS context, right? If you're taking an air taxi from one location to another, what does that look like, and how do you keep people safe in the process? So given that we can do these hyper-localized forecasts, this is something we're looking at contributing to, both in an ADS-B sense, but then also in a weather sense. So this is an especially interesting one, and this one is brand new. I actually just finished going to a conference on this exact topic just a couple days ago, and learned a lot about exactly what kind of weather data is needed for emergency management solutions for wildfire forecasting. So there's a very strong need for highly localized real-time weather data for tactical efforts, right? It's not good enough to know what the weather is over that mountain ridge in a different city. You have to know exactly what that weather is for specific coordinates. And then there is also, a broader interest in weather trends over that geographic area, in the sense of, Is there a cloud front that's moving in, or is there rain coming in? And so essentially, you sort of need all of the above when you're fighting a wildfire, right? You want that localized information, but then also that broader regional information. And we're in a good position to provide both of those for wildfire efforts. There's also soil moisture data, which we collect using our systems. And that's traditionally used as a proxy for vegetation or fuel calculations to know what's at risk of burning. And then, of course, there are also aviation assets that factor into all of this when you look at how do I want to manage a fleet of aviation assets that are putting flame retardant onto a fire. So this is my final one here, and this is a favorite topic of mine. So illicit ship-to-ship transfers. This has been a big focus of the current presidential administration and the government for some time now, and you get a lot of different stakeholders that are involved in this. Everything from defense entities to you get commerce being involved in this, you get Treasury being involved in this. All these different U.S. agencies are involved in this effort to detect illegal ship-to-ship transfers and to ultimately do something about that. And so essentially what this means is that you have a need for both real-time AIS data on where a certain bad actor vessel might be, but you also want that historical AIS data that we store for forensic analysis, so that once you determine that you have a bad actor on your hands, you can look at where they've been and what they've touched historically. So this is something that we're working on right now, and then we're also engaging with some other partners having to do with dark vessel tracking. So the question of what happens when one of these vessels turns off that AIS transponder, we partner with some synthetic aperture radar providers that can help you continue to track one of these bad actor vessels, even if they try and hide by going dark. So speaking of partners, I want to introduce Keith Fraley. Keith Fraley is the co-founder he's a co-founder at 40Geo, and they're one of our key data science partners that does some really interesting analytic work with all of that data that I was mentioning.
Hello, my name is Keith Fraley. I want to thank Spire for the opportunity to speak here today and talk a little bit about our company 40Geo and some of the stuff that we've been doing with the AIS data provided by Spire. Yeah, so my name is Keith Fraley. 40Geo is based in Houston, Texas. We've been around since 2017. The 40 in 40Geo is basically a play on 4 dimensions, and it's the idea that geospatial analytics or geospatial information is inherently 4 dimensions, and really, that time aspect is huge for understanding the flow of information from sensors around the globe. Like I said, we are founded in 2017, primarily focused on geospatial analytics and real-time operational pictures. We have projects on 5 continents, and these are our verticals: oil and gas, shipping and ports, aviation, and here recently we've been doing some work at the state and federal level. Our business partners are ESRI, AWS, Spire obviously is a huge one for us, and Elasticsearch. And really what I hope to talk about today is how we kind of use all of these combined together to provide solutions to our clients. It's important to understand that we are entirely a solutions-based organization. So when we sit down with individuals or corporations, we first ask, okay, what is the actual business problem that you're trying to solve? And from that, we kind of work backwards towards the technology in and of itself. So technology should always be a means to an end. That's the approach that we take. We're a solutions-based organization, and that's kind of what we hope to show you here today with the demos that we have around the work with the Port of Houston and the AIS data that we've been managing. So really where we're at, and it's kind of hard to see, we're at the beginning of the 4th Industrial Revolution. It's kind of hard to see the forest for the trees. But that Industrial Revolution, really in my brain, is because of these eight core fundamental technologies that are on the screen today. So, sensors are important, but sensors without connectivity are effectively very limited. And without big data solutions, it doesn't matter what type of connectivity you have. And you can go on down through this list right here. But the bottom line is that all of these combined together really put forth a compelling fundamental components of the next industrial revolution. And really what this industrial revolution around is massive efficiency gains. So what are our solutions? So we are focused on exception-based surveillance, the idea that we can study trends. Some people categorize this as predictive analytics, things like that. The idea that we can study trends using sensors and really put together solutions. Our revenue streams are from an IoT SaaS platform, a sensor data platform, and geospatial consulting. So we have a spatial platform that we call Raptor. We're more than happy to supplement those feeds with our own hardware developments. So we will actually deploy AIS hardware kits, and that's kind of what you see on the screen here, which is effectively an implementation that we use leveraging AIS data for the Port of Houston, right? So this is real-time information that allows us to monitor not just the movement of vessels. I mean, that's been done for quite some time, but also the monitoring of where those boats go, how long they stay there, and where they go afterwards, right? So that's kind of the big question. We talk about solutions based. The big question that the Port of Houston needed to answer was, how do we actually leverage sensor technology like AIS data that's provided from Spire and help us improve our revenue? And that's what this was about. Monitoring the movements of boats in and out of the port allows them to create more comprehensive revenue streams. What you see on the screen right here is basically some more screenshots of that solution. But really what we're trying to do is provide solutions, right? So a lot of time in geospatial analytics, solutions don't necessarily have to be on a map, right? They can be just the aggregation of the information. It has a mapping component, but really what we're trying to do is provide people quick answers. And what you see here is an example of one of the dashboards that we put together for our partner in the Port of Houston to give them a total summary of minutes that have been spent at their berths over a period of time. As we scroll down, you can slice and dice that data by terminal, by berth, by vessel type, and even by specific vessels. We keep track of the histogram of all that. It kind of goes back to what we mean by the 4 dimensions are so critical. Obviously a lot of this is around the raw data as well. So you can see here that we also keep a historical log of the data. We also do a lot of ability to kind of pause and rewind information. And that allows them to kind of go back and create incident investigation. One of our use cases was the ability to monitor maritime bunkering. Bunkering is basically supplying of fuel for use by ships by other vessels, right? So a tug, typically in Fort Houston, a tug will pull up and fill up a large tanker. Well, that takes several hours, but there's a cost to that. So when that occurs within a facility owned by the Port of Houston, then you own the Port of Houston X amount of money for the amount of time that you spent there filling up your vessel. And so for a long time, this was all done via the honor system. So when they would get a historical log from maybe a provider, but also there was no way of validating or verifying any of this information that any of the bunkering that took place. It was just all kind of the honor system for several decades. What they wanted to do was come up with a way leveraging AIS data to increase their revenue, right? So we're looking at the ability to increase revenue for the Port of Houston. And the way that we do that is to leverage geospatial and AIS technology and automatically detect vessels in the bunkering process and integrate directly into the port billing system. And that's kind of a tricky process because you can't just look at the points, right? You can't just look at 2 dots on a map and assume that they're bunkering. Really what you have to do is draw the polygon outlines of the vessels that are included in the AIS feed and then do the analysis of whether those 2 boats are actually bunkering or not. And what you can see on the screen right there is that's an example of two vessels bunkering. You can see the large cargo ship in red, and then there's a tugboat in yellow. And this is actually a better example here. So this is an example of the GH Levant being bunkered next to this Savage Outlook vessel. And so as long as that takes place inside that green rectangle, those are fees that are due the Port of Houston. And so you can see here is an example of why you can't just do this with point data. You can see that just with the AIS XY of where that event was, it's really hard to decipher what was actually happening there. And so there was an algorithm that we developed on our end that basically monitors every one of these transactions and shows you the polygon outline of it, and then from that derives, okay, this was actually bunkering that was going on, and this is legitimate, and it goes in a historical log and is emailed to the port each and every night. We also provide analytical dashboards, obviously, that can roll that information up into a usable format that people can kind of get in and quickly see, okay, what bunkering is happening at my terminal at this specific berth, what are the vessels that are involved in it, so on and so forth. So that's a little bit about us. This is our platform, the Raptor. Kind of our catchphrase is from sensors to decisions. At our core, we're a Rosetta Stone for geo IoT feeds. We really pride ourselves in next generation geofencing and high velocity data into geospatial systems. And yeah, I really want to thank you guys for the opportunity to speak here today.
Great. So I think the last thing we're going to do before heading into the Q&A, which we're about to get to, is just one more poll. We're curious after everything you've heard today about our different products and what you've seen with the AIS data, kind of what products you might be interested in hearing more about. So I'm going to launch the poll quickly and just wait to get some responses there. Thank you everyone for your quick voting. I'm just going to give this a few more seconds here, get us close to 100% in terms of participation. Definitely seeing continued interest in Earth observation, which is great. We obviously have a lot of different types of data there, so we can connect with you and provide you further information on anything you might be interested in. All right, so we're close to 100%, so I'm going to close the poll out and just moving back to the slides here. So now we're going to move into the Q&A. So thanks to everyone who's kind of
Weather prediction models.
So we can go through some of those, and feel free to continue to send those in kind of as we move through. And we'll be jumping back and forth, each of us kind of helping answer some of the questions. So I'm going to jump into it. So this is a great question. I think, Steve, this is probably one for you. So the question is, can the GNSS, and I think in this case it'll be GNSS reflectometry satellites, can we do flood depth determination with that?
Thanks for the question. I'm not sure that we can do flood depth. That's something I'm going to have to take offline and get back to. Let's see, who was it who answered that, who asked that question? Charlie McGillis. I'll get back to you with an answer on that, Charlie.
Okay, great. So next question here, again, Steve, I think this one will probably be for you, and this is definitely something we've been talking about, is will what's going on with Legato and their 5G network kind of affect our ability to do our radio occultation in any way?
Yeah, sure. So I can just I'll say that I sat in on one of the recent sessions on this exact topic and took notes for us and was participating in that one. The Legato 5G topic, it's definitely one that's of concern to the industry, and it's one where I think no one quite knows exactly how that's going to affect satellite providers yet. I mean, there are obvious concerns about interference with satellite operations, but I think unfortunately that's kind of an open question at this point in time. And so I think that's why there's been so much pushback from the industry on this exact topic is no one quite knows exactly what the impact is going to be of that decision yet.
Yeah, we did join the other industry players who filed in opposition to the Legato application. So we're following that. Our legal team is following that pretty closely.
Great. Oh, here's an easy question for me about getting a copy of the slide deck. So yes, just to let everyone know, the slides will be available after we're done here, and there will be a recording of the webinar, which will be sent to all of you as well. So yes, to both of those things. So the next question, I think for Steve, how can someone kind of get access to Spire Earth information data?
So I mentioned the NASA project, the Commercial Smallsat Data Acquisition Program. So any NASA researcher or NASA-funded researcher can get access to our historical data. We have provided NOAA with some of our radio occultation and total electron content data. So if you're a NOAA person, you can access that data. And we hope to be participating in the commercial data purchase program later this year for NOAA, where we'll be providing our radio occultation and total electron content data for operational use and numerical weather forecasting. If you would like access to some of our data on a trial basis, we're of course willing to provide that. If you contact me or Janie, we'll be able to work with you on that. For international users, we also are partnered with Luxembourg and I believe ESA. So there are mechanisms for researchers to get access to our data through them.
Great. So we have a few different questions coming in here. So this one looks like it's probably for you, Will. So the question is it possible to get an example of the wildfire forecasting model? And I might ask also just kind of what information or data we can provide to folks surrounding that use case, the wildfire forecasting use case.
Yeah, sure. So I can speak to that one. So this is one because it's like brand new. Literally a couple days ago was when I first started looking at this topic and realized there was a lot of potential here. So this isn't one that is a fully built out solution yet, but this is one where we took a look in-house at what our capabilities are, both in a localized weather forecasting sense for point forecasts and also atmospheric, and realized that we probably could perform very well on this topic. And someone does have an interest on the wildfire topic specifically, my email is going to be up on the last slide. And if you want to reach out to me, absolutely. It's something that I'd be interested in having a discussion about, because I also want to try and feel out which exact weather variables that we're already collecting would be most useful. So that's something that I would want to have be an ongoing conversation about what we can do on that, because I could learn a lot from that too. So definitely fire me an email, william.cromarty@spire.com, and that'll be on the last slide.
All right, another question here that I think either Will, you could speak to, or Steve as well, you could certainly jump in. So the question is, does Spire have any active agreements with US civilian agencies for the purchase of AIS and ADS-B data?
Let's see. Steve, do you want to take that one?
Sure. We currently have purchase orders from the U.S. Coast Guard Academy, other parts of the Coast Guard. We provide our data through a third-party aggregator. Let's see, we've provided some AIS and ADSB data to NASA for some research related to COVID.
I guess we've also got USAID that we provided data to for COVID impact analysis. So that's an ongoing one that we're looking at too.
Yep. That's what comes to mind right now on AIS and ADSB. I think we also provide some to some classified customers, but can't really get into that here.
Yeah. Another question, I think, Steve, you touched on this a little bit, but maybe there you can clarify. Is NOAA and like the National Weather Service using Spire's radio occultation data in their numerical weather prediction models?
Not currently. ECMWF and the UK Met Office are currently using on a temporary basis because of the loss of aircraft provided atmospheric data. UK Met Office and ECMWF are assimilating our radio occultation data in their operational numerical weather forecasts. NOAA is not currently, but with the commercial data purchase program that will come out later this year, they will be purchasing radio occultation data for operational use.
Great. And then, Will, I think a last question here for you. So what sort of emergency management and disaster mitigation applications are there for our data?
Yeah, sure. So, I mean, I think I could think of a ton of these. One that comes to mind is flood zone mapping and taking a look at exactly what the soil moisture in a given area can tell you about flood zone risk. There's the fire element in a pandemic sense. What I was mentioning earlier about the ability to look at a specific vessel and know exactly what ports that one has touched in the past. So, if you wanted to do port management solutions in a pandemic time and think about, this ship is coming to my port from Wuhan, and do I need to have a mandatory quarantine period before that vessel touches my port? Or this flight is landing from a certain Italian airport where there's been a spike in coronavirus. In an emergency management for pandemic sense, that could be one. And then also just the ability to have real-time emergency weather data for everything from lightning risk to an airport, wind speed data. And then also we're doing a lot of really interesting work on wave topics too, and looking at exactly how waves are behaving in an ocean sense. So, I mean, really, it's the sky's the limit on all of that. And if there's a specific interest in a specific type of disaster, I think, anything short of earthquakes, we're pretty good at predicting.
Great. So I think that's all the time we have. I know there are a few questions here we weren't able to get to, so we will definitely be following up with everyone and providing an answer to your question. So thanks to everyone who submitted those. And as you can see here, this is our contact information, both for us at Spire and Keith Fraley at 40Geo. So if you have further questions or interest in anything you want to talk to us, please feel free to reach out. And as I said, we'll be following up. So expect to see an email from me or from Steve or Will kind of in the next few days with the slides and with the recording, and then answering any of the specific questions that you had on the webinar. So thank you again, everyone, for joining. Thanks, Keith, Steve, and Will for providing this information overview. I think it was, we got to hit on a lot of great topics that everyone was interested in hearing about. So thanks again to everyone.
Thank you.
Yeah, thanks everybody. Really appreciate your attendance.